everyone. In this video, we're going to look at our question number 7. That is mainly focusing on the sample size for population mean mu. Also for this question, it's kind of review a little bit about what we already learned in part 1 of the learning from chapter 8. Okay, so Dave, the jogger, ran the same route every day, about 2.2 miles on 5 consecutive days. He recorded the number of the step on his Fitbit, and the result were following: 3450, 3363, etc. And so question number 8, what is 90% confidence interval for the true mean number of the step Dave takes on his run? So this question is about the mean. It's not about proportion. So therefore, it is relevant with what we learned from the part A, right? Part 1 of the chapter 8. So we learned 2 formulas. One is confidence interval for the mean when we know population sigma. The other one is the confidence interval for the mean when we don't know the population sigma. So now we need to determine if this is the scenario we know the sigma or we don't know the sigma. As you read through this case, you know that we actually don't know the population sigma. Otherwise, we will be given the question. So the only thing we have is our sample data's value. 5 consecutive days, how many steps he took, right? So therefore, we need to, based on my sample here, this 5 observation, first identify my sample mean. Second is to identify my sample standard deviation. And after that, we're going to use in the formula that is a confidence interval that when we don't know the sigma. So therefore, we're going to use the T statistic, right? So if you don't remember, let me go back to the formula. Okay, so this is the formula we're going to use to calculate confidence interval for our A. Okay, so let me starting from here. First, we need to calculate mean. We need to calculate X bar. We need to calculate S. And then we need the confidence level. And then confidence coefficient. And then we need T stats. Oh no, we need a degree of freedom. Sorry, degree of free. This is 1n. We need a sample size n, degree of freedom. So we did the setup that in our previous video. Degree of freedom. Then we can get T stats value, and then we can get in our lower bound and upper bound. Okay, so first, in order to calculate X bar, we need our data. Okay, so let's go back to the question again. So the number we have here are the following 5. And as I mentioned in the previous lecture from part 8, we need to make sure all the number in the vertical, so in the columns. And I'm gonna copy, paste them. Okay, now I have my observation. Now I can calculate mean. So the mean, we're using the formula called average. And then select the value. Okay, so the X bar equal to 3,341. And the next one is standard deviation, STDEV dot S, since it is a sample. And we select all of them. So that gives me the standard deviation. And then based on the question, the confidence level we are looking for here is 90%, right? So therefore, we're going to come back here, documenting the confidence interval is 0.9. And then our alpha we learned is equal to 1 minus the confidence level. Okay. And then my sample size n here, so we have 5 consecutive days, so therefore the sample size here is 5. And then the confidence level we learned from the last part 8 is n minus 1, so it will be 5 minus 1, that gives us 4. Now we are able to use T stats. So for the T stats, it's equal to T dot INV dot 2T. Okay, so again, if you don't remember, so this part of learning really count on you to practice a lot. So we have a lot of formula on the PowerPoint, but also we have some formula on Excel as well. Make sure you remember all of them. The best way to remember them, just keep repeating, follow my video to practice. Okay, follow my video to practice. So the first entry will be your probability. And then when we are calculating our t-statistic, the probability here is not that complicated. So since it already tell the computer it's a two-tailed test, so therefore we just directly use the alpha. So you don't need to use alpha divided by 2, okay? Just alpha. And then the second entry here will be the degree of freedom we needed. Okay, so now we are able to get our t-statistics. And we have everything we needed to use the formula we just saw on the PowerPoint, right? Let me just copy this one and put it right next to my Excel so we will know how we follow it, right? So first of all, the lower bound is equal to the x bar. We select my x bar, I calculate it. Lower bound is in minus, right? Minus the t-statistics times the standard deviation from the sample and divide by SQRT, square root of sample size n. Okay, so that will give me the lower bound. So 3,262 steps. And my upper bound is equal to the x bar plus t stats times standard deviation divided by SQRT, parentheses, and n. Close the parentheses and then push enter. So now for the 90% confidence, and we believe the population, how many steps Dave make in general is between 3,262 to 3,419 steps. So that is the 90% confidence interval. So that is the answer for A. Okay. Now we move on to B. What sample size would be needed to obtain an error of plus minus 20 square millimeter with a 90% confidence? Okay, so I think there actually should be an arrow here, should be not square meters, but steps. Okay, so you actually had a very similar question in your homework assignment. And so I reported. So if you don't see the change, you need to know for that question, instead of plus minus 20 square meters, that's a typo. It should be steps, because this everything we calculate here is about steps instead of the square meters. Nothing about square meters. So it will be plus minus steps instead of square meters. Okay, should be square steps. Okay, should be square steps. So keep in mind, so that is a typo in your homework assignment. So I already reported. Hopefully, when you start working on it, they already corrected. Otherwise, you need to know. Make sure you know when they ask you for the sample size question, there has to be consist with the initial meaning of your data, right? The data is about steps. It's nothing related to the miles. Okay, millimeters. Okay, so now the question is asked for the sample size, right? So we're already talking about the sample size doesn't mean you need it as large as you want it. So we want the right amount by using a formula. And given people have expectation about the error they are looking for, right? So the error in this scenario looking for is plus minus 20 square steps. So therefore, the formula we're using from our lecture is this one, okay? And so the z times sigma divided by E and the square. Okay, so first of all, for the Z statistics, so what is Z statistics when you're looking for? So it really depends on the confidence interval we just calculate, right? So apparently the people here are care about 90% confidence. So if they care about 95% confidence, you need to recalculating your confidence. Okay, so we are looking for 90% confidence interval, and then that is so if you don't have the part A exists, so when you're thinking about the Z you are using, by default we are using 95%, okay, based on our PowerPoint. And so once you know the Z, we are using Excel calculate Z stats, and for the sigma, and the sigma is the standard deviation, population standard deviation. Since we don't know, in the lecture, right, we talked about, we can base on the preliminary sample to estimate S, and we can use S to replacing the sigma. So that means, since in the part A, right, when we calculating the part A, we did based on these 5 samples to calculate the S value. So we're gonna use the S value to representing the value for sigma, and the E is our margin of error, and we are already given from this question. So therefore, what we need to do is we do need to calculate our Z stats, and instead of T, right? A, we're using the T stats, but we are calculating the sample size, we are using the Z. So when we're recalculating the Z statistics, and then the second is, then we just put everything together based on our formula, okay? Now let's move on to the Excel. So the most important thing you need to figure out here is the Z stats, because we only have the T. So for the Z stat we are using is norm dot S dot INV parentheses. So the probability, remember, is the Z, so therefore we are using the confidence level plus the confidence coefficient divided by 2. So that is the insight we need to use for the Z stats. So that will give us the Z statistic for the 90% confidence. Again, if you question number A already telling you it's 95%, so then you will changing this value correspondingly. So now after we got Z, and we also had the E's value, right? E value they give us is 20. Okay, and then also for the sigma, we estimated, right? So that we are using the estimated S value. Okay, so now we have every piece we needed. We just needed the formula again. I'm just copy that formula back here. So do you know how to formalize, right? So our sample size N, we are looking for, will equal to the parentheses and a Z times sigma divided by our E. Close the parentheses. Don't forget power means caret 2. So that's gonna give us the sample size we needed to estimate mu. So we approximately need 45, 46. So 45, 46. You can round it up or round it down here. So I would just pick 45. So we will need a sample size 45 in order to estimate the value for mu. Okay, so hopefully this video will help you to understand how to leveraging that sample size formula to figure out the sample size you needed to estimate the value for mu. So if you have any question, feel free to reach out to me. Bye.